First, we have a description of our physical device.
So this is the physical setup of our device, including ECE2305 transceiver and Arduino Uno. So as you can see, the set pin is connected to digital pin 4 on the Arduino, and TXD is connected to digital 5 on the Arduino, and then RXD is connected to digital 6 on the Arduino. Also, an antenna is soldered on the transceiver to increase our range, and a USB is plugged in to power the Arduino, which also outputs a 5 volts to the transceiver. As you can see, the RX and TX LEDs and the blue LEDs are blinking. That means we're uploading the code, and if we transmit a command, the TX LED would blink again, and if we receive something, the RX pin would blink again.
Next, we will have an explanation of the flowchart of our team's final design.
So our first issue we had to solve was finding the frequency and channel that the node was transmitting on. We developed two methods to do this. The first and most basic was using the RTL SDR. We would scan through the frequencies between 433 and 473 megahertz. We would look for the trademark signal, which was a heart-shaped signal that would pulse 3 times. And we would then do a simple math calculation to convert that frequency number into whatever channel number was appropriate for the HC12. From there, we would use an AT command to set the channel for the HC12, and we would know that we were on the correct channel when we would get a IP address transmitted back. Using only the HC12, we developed an Arduino command that would scan through all of the channels and detect whether or not an IP address was being transmitted at that channel. If it was, then we knew we had found the proper channel and frequency that the node was on. Regardless of which of those two steps you take, the next step is sending the authentication packet. This is transmitted to the mystery node in the format MAC address, IP address, password. If we received a response, we continue. If not, we would continuously send the authentication information until the node responded properly. Once we were properly authenticated, we could send the getFlag command, which is using the same packet setup, only instead of sending a password, we would send the command get_flag. If we received the flag back, which was sent as MAC address, IP address, flag, then we knew the entire procedure was successful. If not, we would continuously loop that command until we finally got the desired flag.
Next, we will have a demo of how our team found the flags.
So right now we're searching through the frequency band, and we were able to find our signal at 461 megahertz. And to figure out what channel we're on, we go to our spreadsheet that we created that converts from frequency to channel, and we find 461 megahertz, and we figure out that it's on channel 70. So we pull up our command window, and we type in the AT command, and we type in the correct channel to find the node that we're closest to, which is the one with the best signal. So we switch over to that channel, and we get the IP address, and we use that as our header, and then we have to use our MAC address and our password as the data of the transmission. We paste that into the serial monitor, and we send it to the node. And then once we send it to the node, we wait for our authentication, and we see it right here. And then we paste both the IP and the MAC as the header again, and then we send the getFlag command as our data. And we send that to the node as well. And we get our flag.
Finally, we have an implementation of our automated command mode. So first, we enter the AT command onto channel 70, which will allow us to enter the correct channel to hear the IP address from the node. In the background, the HC12 will be collecting the IP address, So when we send the command send password, we're able to correctly format our packet and get the password and get our authentication. Then we will send the command find flag and we get the flag. Now we will go over some concluding thoughts on the project.
We were able to connect all the nodes and collect all 4 flags. There were a couple of challenges we ran into. When changing baud rate, our HC12 would often stop responding to the command line, unless it was reset to default. Thus, we were only able to connect the nodes when they were transmitting at the 9600 baud rate. We also implemented a find channel function. However, because of the frequency and baud rate hopping, the function would scan too slowly to reliably find an IP address. There are some modifications that can be made to the code and to the HC12 setup in order to achieve more optimal results. However, the group was able to learn a lot and reach all of our goals.